Okay. Good afternoon, everyone. On behalf of agricultureinformation.com, I like to invite the speaker, Ms. Ritu Panwar, who will talk about water revolution in farming with super absorbent polymers. Fasal Amrit. I now request the speaker to begin. Thank you.
Thank you so much. So here, Ritu Panwar. Basically, I'm product development manager in a private firm, EF Polymer Private Limited, and we have this product Fasal Amrit, which is a super absorbent polymer. And today's session, basically, we are going to talk over all those aspects, how we can better revolutionize, or we can say bring a better water management system in an agriculture. So, as if we talk over whole global aspect, basically there is a huge water crisis, and as we all know, the fresh water is being declined by a lot. It is FAO's data that the 70% agriculture water is now using the fresh water, and as per reduction, if I talk from the past, 40% of water availability has been reduced, and it will reduce on a huge level in upcoming till 2050 and more. Similarly, food demand is also increased, and by up to 60% it is increased so far, and in the future it is going to increase more. And to meet those food demand or hunger demand, we have to grow more. And by declining the water level, definitely that is something which is a huge aspect or huge issue for us to take forward. And as it is the fact that around majority of our farmers are under rain fed, they are dependent on the rain fed situation. It is more of a depletion aspect, or we can say the drought aspect, which they are facing a lot. Around 54% of agriculture is under our rain fed farming. So that basically creates a scenario where more water demand is needed, more food demand is there, and we are not getting enough of supply of any. So why this particular thing is so far is a challenging, because the current water management systems are having some limitations. Some conventional methods we are having, like to make the water or irrigation aspect more efficient, and that is drip irrigation, mulch techniques, some irrigation scheduling we can do. There are more like a sprinkler and all those, but these all can increase the efficiency of irrigation applied water, basically. But it is not working on a retention aspect, it is not working on a soil level, it is not helping in any extension of the irrigation, basically. And the main problem, the core problem, is again water holding capacity, its retention capacity. By regular use of chemicals, by regular use of the inputs which we are using at the moment, is basically reducing the field capacity. And it is the scientific percentage that we received is around 10%. It has been declined from the past. So these are some challenges which we are facing, where the current technologies, conventional methods are not giving efficient manner or efficient support to our agriculture. So here comes the part of super absorbent polymer. Basically, what is a super absorbent polymer? If we say super absorbent polymer is basically something which is made up of a single unit in a multiple chains, but it is having a capacity of absorbing many folds by its weight. So usually, often super absorbent polymers are having absorption capacity from 200 to 400 to up to 1000, as for if we go for the chemical aspect. So there are various type of super absorbent polymers, like synthetic SAPs, organic SAPs. There are some semi-synthetic as well. So those SAPs are basically having the property of absorbing the moisture by its weight. So if we say 200 times, so by 200 times its weight, if we are taking 1 gram, it is going to absorb 200 grams of water or 200 ml of water. additional water basically we are talking. So basically this product, when you put into the field, it is going to add an additional field capacity to your particular field, and that is how it is tackling the situation at the moment. Now, there are certain criteria like synthetic SAPs. Basically, they are made up of polyacrylamide or polyacrylates. They are having high absorption capacity, high absorbency, even up to 1,000 sometimes. But there are having certain limitations there because it is a chemical. It is not biodegradable one. It is going to accumulate onto the soil, and it might have certain environmental concerns, considering it is a polyacrylamide. Then there comes the semi-synthetic ones, which are basically made up of organic material, but during the process some chemical or processes have been used which made it as a less biodegradable. Though it is biodegradable, but in a long term it is going to biodegrade, which might not be feasible. And then comes final, the organic one. Definitely, those are some product which a farmer can use without having much of future issues or any issues of any chemicals on their field or something like that, accumulation kind of issues. So basically organic SCPs are made up of bio waste, complete bio waste, and end to end the process are also organic in nature. So if our farmer is doing complete organic farming, then also those kind of farmers can utilize it. So those are some pros, like it is having organic in nature, so it is not going to harm your soil. It is going to help your soil improve. It is going to add carbon in it. It is biodegradable in nature. But again, as we are going for the organic, there is slight limitation that its absorbency is not that much as of synthetic one. It sometimes reach around 200, even 50, but those are beneficial for agriculture because lower the absorbency is more supportive for the plant by having not competing with the soil basically and holding the moisture which is extra. So how basically this SAP is working in a soil dynamics, and how it is actually having a cycle, how it is working, how it is flowing. Basically, whenever you give the irrigation or whenever there is a rain which is going to be received, this particular product is going to absorb, swell into the root zone, and then when it is needed, it is going to release the water. In whole this process, it is going to reduce the losses of any water which might be extra, which might have run off, which might have evaporated, and which might not be able to available for the plant. But this product is holding that moisture and it is releasing it back. Then because it is organic in nature, and at the end of crop cycle it is going to biodegrade, so basically it is going to improve the soil quality by adding organic carbon and matter. And finally, because it is having the capacity of holding moisture, along with the moisture it is also going to hold any input, nutrient or maybe fertilizer, whichever you are putting. So it is also helping in improving the efficiency of whatever input you are putting. So altogether it is one of the core products which is not just saving your water, it is also saving your input, it is improving your soil, improving your crop yield, and finally it is saving the water use efficiency. These are some general proven agricultural benefits from the SCP, or we call it a hydrogel because it absorbs the moisture, or hydrogel, water basically. So it helps in improving the water retention capacity up to 30 to 50. So basically, if your soil is having certain water retention capacity, it will going to improve it. So in basically in the sandy kind of area or arid kind of area, where moisture retention is the main problem, there basically this kind of product will help in retaining the moisture which might have lost. It has been improving the irrigation efficiency by reducing the number of irrigation that is needed, again because it is holding the moisture. it is improving the capacity and retention. It is going to make the soil more moist, or make the soil have the moisture available for the longer duration, and it is actually demand less of irrigation. Then the yield increment, if water is being utilized efficiently, if inputs are being utilized efficiently, at then it will affect the yield, it will improve the yield, and per drop of the water we can get a better yield. So definitely it is going to improve the water use efficiency. There are certain research aspects which has been taken, and it shows that it not just improve the moisture, it also improve the seedling survival rates in some particular nurseries or agriculture aspect where it has been used. So where the mortality rate is high because of drought, because of stress situation, or because of high heat or low temperatures, this product can help in improving those survival rates by maintaining the temperature and by providing the adequate moisture. This particular product, Fasal Amrit, which we are talking, basically, it is one of the innovation which is having a organic in nature, made up of banana peels, orange peels, complete fruit bio waste. It has been made 100% biodegradable, and it absorbs up to 100 times to 200 times of its weight the moisture. It is having dual function. Basically, it is absorbing moisture, it is regulating the moisture. Along with that, it is also improving the soil by adding the organic carbon, organic matter into the soil, and making the nearby nutrient more solubilized, and improving the fertility of the soil. There are some instances which have been observed that if particular soil is having clouding, a heavy soil composition, basically, this product had actually helped them by making the soil more of a friable, soft. It basically makes the soil friable and soft. So that is how it is helping a better anchorage of the roots. In comparison to synthetic SAP, this particular technology, though it is having a less of absorbance, less of absorbing capacity, it is biodegrading into 6 to 12 months, very readily biodegradable. There will be no trace of it on the field. It actually leaves organic carbon and matter, which is going to improve the soil fertility. So it helps in improving soil. Carbon addition is there, and at the end it is sustainable. So hence it is environment safe as well. There are certain proven data, set facts, which actually results, which actually shows that how this particular product is helping against the traditional technology or traditional farming a farmer is doing. So one of the trial in a sugar cane that has been taken, where 9.6 million liters of water that has been used, and 39 metric tons was observed. Where this product has been used, it only used 4.3 million liters of water, and we got 41 metric tons. So increase yield and reduce irrigation, that basically helps the farmer to have a dual benefit. They do not have to put much of input, and they can get a better output, basically. Similarly, one of the rainfed situation, we have done the groundnut trials, and we found that though there was a huge dry spell, farmer got around 15% higher pod yields. And if the pod yield are higher, definitely at the end the seed yield would be much more higher than what is expected. And it basically demonstrate how this particular technology can be helpful in water limited conditions, or where we are talking over the resilience, crop resilience, or environment resilient products. So basically this product is a go to go kind of product, or we can say more of insurance, a crop insurance kind of product for any farmer, where they do not have to uh, go for any crop losses, basically. Then there is one of the result which we have taken in a nursery. There we have found increased survival rate of the seedling up to 18%. Usually it happens in a nursery case, lots of seedlings actually die during the transit, during the development, and at the end, per seedling cost that they have kept in initial, and then when they have to sell they have to recover whole, and hence the seedling cost actually increases. So by increasing the survival rate, the cost per seedling has been reduced or balanced, and hence that is how it is actually helping in the nurseries as well, by providing an additional moisture situation. Water productivity, as I was talking in previous slides as well, how water productivity is basically a game changer basically in this particular agriculture segment with SAP. So as we know, this sugarcane trial, they the particular water use as efficiency or the water productivity comes out as an a 4.1 kgs per meter cube, while in case of treated where the product has been used, it is 9.5 kg per meter cube. And that difference is basically a huge difference a farmer can get in exchange of this product or the cost that they put in the product. And this increasing yield with per drop of water is helping them improve the income source, helping them improve the at the end of production, or they have a better market prices, they can fetch a better market prices altogether. On a sustainable aspect, if I talk, so this particular product is not just environmental friendly, it is also economic friendly, because it is saving water, it is improving soil, for which usually farmer put lots of inputs. It also help in reducing fertilizer and provide a better yield with reduced fertilizer as well. And altogether it is at the end when you get the production, it is more than the traditional farming practices. So altogether farmer is getting additional benefits by reducing some inputs and by increasing the output, and hence farmer is not working on a water conservation, it is also getting a better economic returns. And at the end the soil is getting improved, which actually takes long for the in a natural process. This particular product is going to improve the organic carbon and matter in a long term. We also works on an SDG goals. So by using this product, basically we are reducing the hunger aspect. We are working on a clean water, or providing water, a clean water to each and every agriculture aspect, and efficient water usage. And at the end, because this product is made up of complete bio waste, we are reducing the greenhouse gas emissions. So at the end it is working on a climate action part as well. Altogether, super absorbent polymer can basically help a farmer by putting some extra input. It can save moisture, and if for suppose there is a long dry spell where farmer uh, tends to have a loss of crop, this product can save their crop even in those kind of situation. And if there is a water as well in that situation as well, farmer can get additional yield by reduced water usage, and hence they can reduce the cost of water, and they can increase the at the end of yield of the farmers. There is one more part which basically we have observed by using super absorbent polymers. Basically this was it was our own experience that we have taken into the field. Farmer actually got a better shelf life of the fruit. It mainly more supports in an water exhaustive crops like vegetables. So farmer got a good yield, those kind of yield which is having a higher shelf life, so they can keep it for the longer duration. Also they can bring an early harvest, so they can bring the product to the market very early, and hence they can fetch early market prices as well. So altogether by adding this product, farmer is somehow adding an extra water reservoir along with soil booster, basically I would say soil booster, which will improve their soil, which will help them conserve more moisture of the soil with the reduced availability of water, and at the end get the better benefits or higher benefits. Yeah, so that's all for the topic. Thank you.
Thank you, Ms. Ritu, for the detailed presentation. Now we'll take up some questions.
Yeah. So sorry. Yeah, please go ahead.
Okay. Okay. How do super absorbent polymers like Fasal Amrit work to retain and release water in different soil types?
Okay. So basically, this product works as a sponge, and how a sponge is like absorbing water, and when you put an external pressure, it is going to release. Now, in a different kind of soil, there will be a different water absorption capacity by their own, right? So, if we talk about a black soil kind, they are already having a enough moisture holding capacity. If you put the product there, the additional moisture which might have been lost by runoff evaporation, that additional moisture this product will hold. When you having an excess of moisture which might have the tendency of losing, those only can be held by the product. Now when external pressure is given here, what external pressure is there? Osmotic pressure is basically an external pressure. So when external pressure is given, this product is going to release the moisture back to the soil and make the soil moist, and it is going to give the moisture back to the plant. It also works when the plant is going to have a transpiration pull or a root pressure, basically the process by which a plant is absorbing moisture from the soil. Same kind of effect it is having on the product. It is going to release it back to the plant. If we talk about the sandy, the doses basically are more, but the functionality is the same. It is going to absorb the excess moisture. Now because in sandy, lots of moisture are being tend to lost by the percolation infiltration losses. So that majority of water which are tend to be lost are going to be stored into the product.
Okay. And what are the key differences between Fasal Amrit and other water retention products available in the market? Hello? Hello?
Yes,
Hello?
please.
Yeah. You can listen to the question?
Any more query?
Yeah, once again.
Sure.
Okay. What are the key differences between Fasal Amrit and other water retention products available in the market?
Okay, so as I said, there are various super absorbent polymer grades, right? Some are synthetic SCP, some are semi-synthetic, and some are organic. Fasal Amrit basically is completely organic with certification. We have organic Japan certification, RSOCA, NPOP. We have organic, then EcoCert organic attestation we are having. So that actually shows that this product is end to end organic. It is made up of complete bio waste, and like in any other product into the market, basically there are one challenge which often visible on the field, and that challenge is they actually absorb a more of moisture from the soil, which actually makes the soil more dry. If the uh, actual absorption or the enough moisture is not given to the soil, so that is in a way started working as a negative for some plants, some soil types. But this product is having a slow absorption speed. So first it let the soil get moisture, then whatever excess moisture is there, it is going to absorb and it is going to release back to the plant. That is one benefit of this product. Second benefit is basically, as I said, it is made up of fruit peels. So we know definitely fruit peels are having lots of nutrient in it. So this product, it is intact with lots of nutrient which is derived from the fruit peels, and those nutrients, when it is biodegraded, it is going to release back into the soil, and it is helping in improving the soil fertility. So whatever available into the market, they are having their own pros and cons, but the main challenge which often a super absorbent polymer user in a farming community face is, what if we are having not enough of moisture, and if your product we have applied, it is going to absorb the moisture back from the soil, and it is not going to get the moisture back to the plant. So those two problems are being solved in this particular product we are having.
Okay. And what is the recommended dosage and method of application for different crops and soil conditions?
Okay, so we have a standard dose based on an area. So 5 kg per acre is recommended dose. It is for the normal type of soil. So more the sandy soil, you have to increase the doses. So from 5 to, we have to increase it up to 7 kgs per acre. If the soil is more of a clay in nature, you have to reduce the doses by the 3 kg per acre. So from 3 to 7 kg is the range of the product to be used. As per application method, this product can be applied in a general practices. So if farmer is going for the broadcasting, this product can be broadcasted on the field, and then a field preparation can be done, and this will actually mix the product into the soil. If farmer is not going for broadcasting, they are going for line sowing, then this product can be used in a seed cum fertilizer drill. Just it should not be mixed with the seed, it should be put into the different box, maybe fertilizer box we can put, and a sowing can be done. But the thing is, it should be applied during the field preparation only, and it should be mixed thoroughly into the soil in order to make it reach near to the root zone. That is actually how it is going to work at an 100% efficiency. If farmer is not able to apply during the field preparation and they still want to apply, then also it can be applied, but in a later stage it can be applied as an when interculture operations are done. So during interculture operation, a side band application can be done, and it should be covered into the soil. It should not be kept on the soil surface, as it is going to create a soil hard pan.
Okay. Um, First, Amrit be combined with fertilizers or organic manure during application, or should it be added separately?
It can be combined. Just we have to avoid it with urea, because urea is actually hygroscopic in nature. It absorbs moisture from environment, and it is going to create the clots when you mix the Fasal Amrit with urea. But otherwise, it is not showing any ill effect with any kind of fertilizer. It can be mixed and it can be applied with like organic kind of fertilizer. I would suggest it is not much feasible with the prom which we are using. So other than that, it can be used with any kind of fertilizer and any kind of organic manure. It should be just not much of the the moisture should be low, because it is, if it is moist in nature, whatever you are mixing it with, it is going to make the application process tough. It is not going to create any reaction, but it is going to make the application process tough.
And how does using Fasalamrit affect irrigation frequency and overall water consumption as on per acre basis?
Okay, so the test that we have done so far, what usually happen is farmer apply irrigation when they see that field is dried. Now let's suppose farmer is applying irrigation in after every 3 days, and because the field is getting dried. But with this product, definitely when whatever you have applied, it is being hold for the longer duration, because it is not letting the moisture evaporate, it is not letting the moisture run off or deep percolate, right? So in that situation, what is happening, it is just extending the duration by which the water is being held. So instead of 3 days, for suppose it is holding for the additional 2 more days. So in place of 2 or 4 more days, let's suppose. So like in 1 week, you are putting two irrigations for traditional practices, but with this product, we are putting one single irrigation per week. So in a single month, where you are putting 8 irrigations in a traditional practice, with this product you just have to put only 4 irrigations. So outright 50% reduction you can observe, and that is one of the trial data that I was actually dictating right now. Like 3 to 7 days interval we have extended, where every 3 days the irrigation was given with the product. After every 7 days of irrigation, then also we have found increased yield of 20%.
Okay. And how does, okay, you already answered. What are the long-term effects of repeated polymer use on soil health and microbial activity?
Okay, so as I said, it is 100% biodegradable. So after 6 months, it is going to biodegrade into the soil, and after two repetitive usage of the product, it actually helps in improving the percentage of organic carbon by at least 1 or 2%. And if you keep repeating it, keep using it, it is basically going to reduce the water usage or water dependency of particular field, and it is going to improve the organic carbon, organic matter, and soil friability. So basically that soil is getting rejuvenation by adding this product on a repeated manner.
Okay. And is Fasal Amrit suitable for both rain-fed and irrigated farming systems?
Yes, so as an irrigated, I said, if you can see the data here, we have taken test in irrigated situation as well, and we have taken the test in a rain-fed situation as well. If we go for the irrigated situation, definitely farmer is having hold that they can reduce the irrigation, and by reducing the irrigation, they can save the water. In case of rain fade, basically if there is a lots of rain, then definitely farmer is not having any hold on holding the rain fade situation, or maybe we can say the rainfall. So water will be there for the control or the product applied fields, right? But in that situation, maybe let's suppose, we are, as I said, we are going to take it as a crop insurance as well. So for suppose there is a long dry spell of maybe 20 days, 8, 10 days, and crop is at very sensitive stage. This particular stage, where in a control situation or a traditional farming, farmer might lose some of its yield because there is a stress situation and the loss will be visible into the yield. But with this product, it is not going to create any such stress situation. It is going to keep making the soil moist. It is going to keep releasing the moisture the much it is having, till the stress situation or till the dry spell can be omitted. So that is how basically it is working as a crop insurance. Now if situation comes for, say, there is a lots of rain, if there is waterlogging situation, then will that product be a negative? So no. We have and this is the experience part basically. There was certain farmers in a Gujarat segment, and they were facing beeper joy, and that actually make their field flooded basically. And in those flooded field, lots of farmer actually lost their crops because of the heavy water stagnation. But this product, where the product has been applied, the crop loss was very low. It was not because of the stagnation at all. It was because of whatever the heavy rainfall was there, but it was not because of the stagnation at all. Now, why it is not affecting because of stagnation? So, in case of stagnation, there is a lack of oxygen into the soil. So, plant actually dies because of lack of oxygen. But this product, along with holding moisture, it is having air pockets. So it is not going to get plant die out of suffocation. So that is how it actually extended the duration the plant can survive. And that is how it is helpful in high water area as well as low water area.
Okay. Mhm. How does how does its performance vary under extreme weather conditions such as drought and heavy rainfall?
In case of drought, it is going to show a excellent result because there is a moisture stress, and definitely how you are going to see the excellent result, you are obviously going to compare it with the field which haven't applied the product. So when the field where the product has not been applied, it is going to take the toll of the heavy weather eradications, or we can say erratic weathers, or dry spells. And those will actually affect on the yield or maybe the greenery part, and it is going to reduce the crop health. Now where the product has been applied, it is going to thrive basically, because it is not going to have any effect of the drought it is facing, because in the field, in the soil area, it is having the moisture itself. It is not going to face any dry spells. So at then it is going to thrive well, and in comparison to that, it is going to be a better result. But in case of rainfall situation where heavy rains are there, in that situation as well, it is not going to show any negative yield or negative effect. It is going to improve yield, though there will be no water saving that you can observe. But at the end, you will find yield improvement in any situation, whether it is a heavy water or more water available or less water available. In both the situation, you can have a yield improvement. The yield improvement percentage may vary basis on availability of water or basis of the crop and the environment, but there will be a certain amount of yield improvement.
Okay. Mhm. And what scientific trials or field results has EF Polymer conducted to quantify yield improvement and water savings across major crops in different agroclimatic zones?
As in a different agroclimatic zones, if I say, there was one of such trials with AICRP maize. We have done where we have taken around five agroclimatic zones in a single trial for 2 years, and the particular trial actually conveys us that this product works nearly same in each and every agroclimatic zone, except in one location where we were having a huge difference into the yield from control to treatment, and that was because of heavy dry spell that was observed. Otherwise, in any agroclimatic zones, there was an improvement of the yield. There was a better crop health, and if not much, then at least 5 to 10% of yield improvement was there. And at the max, if I say, there was even 38% of yield improvement was there.
Okay. So, okay. So before we wind up, please let us know little about your career background and what made you to take an interest in agriculture subject.
Okay. Yeah. So, my as an educational background, if I say, I am masters in horticulture sciences, agriculture, and this particular startup, EF Polymer, where we were working basically. So this idea actually come up as a science project itself in earlier education era, first or second year. And since then this product was taken into the lots of R&D trials, lots of validation. I have joined this organization when it was actually working on a validation part, where we were having a very small number of trials at the hand. And since then I have worked on lots of crops, lots of I worked with lots of universities to get the validation. And at this point we are having a complete validation of this product. Like this product can be used in each and every kind of agroclimatic zones, what could be the doses, what could be the segment we can work on, and all those. And motivation, if I say, for the agriculture, taking up the agriculture. So basically I love to grow plants even in my early era, before I have taken the agriculture. And I used to grow lots of gardening plants and all those. So that actually helped me get into the interest of that particular part, that we can have some scientific or research mindset behind these plants as well, or we can work on these plants. And then as of my keen interest in a research, I came to the agriculture segment, and in a research segment specifically. And my only motive to work here is to develop something which is not actually making any negative, or we can say any kind of harm to the environment in a long term. So that is a basic motive to work.
Okay.
Yeah.
Okay, Ms. Ritu. So I don't see any more questions. So now we have come to end of question round. On behalf of
Sure.
agricultureinformation.com, we'd like to thank you for the presentation and answering all the
Sure.
questions. So we'll be ending this meeting now.
Sure. Thank you so much for your
Thank,
eating. Thank you.
thank you. Thank you.